So, good morning from me. I'm very happy to be here. It's the second time in Poznan. It seems it's gotten lovelier in the last 3 years. I want to talk to you about database as a service, or basically Postgres on Kubernetes. I will have a few slides telling you how we get there and why we did it. And I also promised you basically some learnings in the end that we got from the last 2 years, more or less, in production. So let's have a look. What have I been doing? I have been in Zalando since 2011, so almost 8 years now, or basically 8 years. I joined in a team that was basically the database team back then, very boring Postgres in the data center, static machines, nothing dynamic, everything fixed. I joined the platform software team, developing software basically, took over the monitoring project, so ZMon, maybe you heard of it, you will have a few slides showing our monitoring. Then I moved to Stups, that was our cloud consulting team, basically, building the AWS infrastructure and working with teams to migrate to the cloud. And then in 2017, I was given the database team at the time. It was 7 people strong. And I basically took over to bring the database team onto Kubernetes and make the cloud more self-service oriented, because this was basically the biggest problem. If you wanted a database, there was a Jira ticket in between, and Jira tickets are slow if you don't read them and don't respond. So the whole idea was to let's have a button and you get your database. Why is it fun to work at Zalando? It's because we are big, we have money, and we have a lot of visitors. That means a lot of data, a lot of projects, and you can normally basically actually have a reason to build your own stack. You're big enough to make some arguments why it makes sense. You are on AWS, which also gives you as a database team a lot of flexibility. Like you have still the ability to scale up, scale down. You don't have to work with long contracts, wait for hardware delivery, and so on. That is actually why it is quite enjoyable. The other good thing about Zalando, we'll come to it later, is we do a lot of open source in my team. So I hope you heard of some of our projects, but Alexi and Alexander and so on managed with one of our projects to basically create the de facto standard in Postgres for high availability. It's called Patroni. That is what's powering our databases in the cloud right now. How did it look like in the old world? Why did I make this joke about Jira? That's how it looked like hundreds of teams creating tickets for databases, and everybody can imagine this simply doesn't scale. So when we go forward, basically quickly, year 2015, we went to AWS. Every team got an AWS account. They could do whatever they want, and that obviously performs much better in the end. Although right now we're looking back now at 15 different frameworks, 10 different database technologies, so this is the different side of the story. In 2016, then we decided to go with Kubernetes for various reasons, and we basically decided this is the right time to use an API to automatically provision databases and to find out how to do this. And that's where we basically are today. 2017, I think, 17, we went live more or less with the first databases on Kubernetes, and I will show you how this looks like. Briefly about Kubernetes, we have a team that manages Kubernetes, so that's basically deploying Kubernetes on top of AWS infrastructure. We are not using Amazon services for Kubernetes, so neither Fargate nor Elastic Container Service. It's the opinion that this is simply not good enough yet, but for us, basically, very happy. We have an amazing team powering Kubernetes, very reliable. We rolled out 1.13 last week, so we are not behind. We are not lacking any features. On top of this, maybe to show you here, what has changed nowadays, the database team basically maintains classic development flows. So we have applications, we have build pipelines, we have deployment pipelines. There's not so much SSH anymore. There is no Puppet, there is no Terraform nor anything. It's basically all going through development pipelines and the classic Git workflow. We'll come to it later. And this is actually why I think it's fun. So many of these projects are open source, and we're doing much more coding nowadays than really troubleshooting on some host. Let's talk about Postgres as a service, how it looks like. I hope everybody knows Postgres, like in one slide here, why it's amazing. So I think the biggest thing is you can do table changes in production without impact. There's not many databases who can do this in a transactional manner. Concurrency is great. Maybe the slightest shortcoming is Postgres Vacuum, but maybe Postgres 13 fixes this. Solid owner and privilege system, that's really great, and it's highly customizable. So there's a lot of extensions, including JavaScript and Python if you really want to use it. But all in all, we started with release candidate 9.0, so like Postgres 9.0 release candidate 1, and have never basically had any bad experience with Postgres. How does it really look like? So where is my experience coming from? So we look at over 200 databases in the data center. We look at roughly 160 now on AWS because this number is shrinking. We are moving stuff to Kubernetes here. And nowadays more than 800 on Kubernetes. And this is basically showing you the moment you enable a team to use a user interface or deploy databases via their deployment pipeline, it will take off. And that's basically the big change here. So from like a Jira ticket earlier, 2 days until you read it, 3 days until you created the database. It's now like deploy this manifest and 3 minutes later you have your database, you have your roles, you have your table space, and you're good to go. Yeah, I already mentioned AWS is fun. You have the fast provisioning. You're very flexible in hardware configuration. So from M4, C5 for compute, more memory, local SSDs, it's all there. And this can help you solve all the problems you basically run into. And Zalando Docker was enforced from day one, so for compliance reason and needing to know what's running everywhere, so Postgres had to go into Docker. And if you Google this, like it's a 50-50 chance you find an article who hates Docker or doesn't hate it. From my point of view, it's really great. It solved a lot of problems for us, for packaging, for running the same stuff locally than in production. We run the same Docker image now on Kubernetes than we run on Amazon, so this is also like really helpful. Back then, we expected a lot of failures from EC2 instances. Simply not true. EC2 is really stable. I made this remark yesterday. Like I think once a month, I get an email that an instance is dying, and you have 7 days to fix it. So that's pretty great. And this basically created the desire to build Patroni back then. And that was basically the daemon that manages a Postgres cluster, makes sure there's always one master database up. And if an EC2 instance dies, it makes sure if a new one comes up to Bootstrap to copy all the data and join the streaming replication. And that's basically what you want. You don't want to wake up for this. And I think it's quite a success story. When you Google it, there's a lot of Postgres consultant companies who use it. You will find IBM's Compose blog, who says their cloud offering, their commercial offering, switched from their own solution to Patroni, I think beginning of 2018. Pretty amazing blog post to read and quite a success for the people who created Patroni. Here in numbers, why it can make sense. So RDS gives you elastic block storage backed instances. You can basically get one storage where you get roughly 3 IOPS per gigabyte, or you can pay provisioned IOPS volumes, but they're really expensive. And what we basically use is the ones with local SSDs, and you see the comparison here. Like you get like 35,000 writes for 270 euros. It's quite more expensive when you use the other side. And for Aurora, it's even more expensive because you pay for the writes. If you're later interested to talk a little bit about the AWS solution, there is one slide here, basically very classic, really 3 Amazon EC2 instances running this. The Postgres talking to each other with everything that's open source. There is no magic here. Load balancer, elastic IPs in front of it, and S3 for backup. That's like how everybody does it and how you should basically do it. So I'm skipping this. Yeah, coming back to the database as a service thing, convenient to create a new cluster, enable all our employees to change the database settings without our work. So you want to increase storage, CPU, memory without talking to us. Integration came straight into deployment pipelines because production changes need to have 4i approval. So basically, if we start doing anything else, we need to rebuild like these flows again. So we decided this also goes via Git. Then it's approved pull request. It goes into production. It's fine. We wanted to deliver decent monitoring out of the box because we had this in the data center kind of. And in the end, obviously, we wanted also to be cost efficient and depending on the user pattern to offer a great solution. I mentioned this earlier, for example, for test environments, Kubernetes Postgres operator is great. You put it all on spot instances and you have a very, very cheap infrastructure to run your test environments on. Yeah, how does it look like nowadays? You put a YAML file into a Git repository, you commit it, you merge it, it gets deployed into the Kubernetes environment, and from there on the idea is the Postgres operator picks it up and creates your database. And on Kubernetes, this kind of needs to be done because what we use is stateful sets. And when you look at one Postgres cluster on Kubernetes, there is the stateful set, then there is services, and there is volumes and all this stuff. And if you tell your engineers, okay, now you need to do this by hand, this doesn't really work. They will go back to RDS, click this button, and get this database. But the stateful set is exactly for that use case. So what we did in the end, we kind of abstract around all these changes, and Kubernetes gives you a nice API to watch object changes. So we see, okay, a new manifest has been created. Let's create a new stateful set. We see some of these manifests have been changed, so let's figure out what's different and maybe increase the volume and so on. What else do we do here? We do the resizing of volumes, quite important for our users. So database size always grows. So that's like the most important feature, changing disk size at runtime. And last but not least, for us, it's obviously important to keep this infrastructure up to date. So by basically releasing new Docker images for new Postgres minor versions and so on, we trigger like a platform-wide rolling upgrade. So like last week, new Postgres minor version came out. We built with the pipeline a new Docker image. It's a new dependency, triggers another production deployment with some testing in between. We'll come to this. And then the whole Zalando platform, all databases are more or less upgraded in 2 days without anybody doing anything. If you haven't worked with Kubernetes so much, the key part is basically, this is how small your Postgres definition can look like. So you have something like number of instances, your Postgres version, and that is all you write, and you put it into Git, and you're good to go. People will come to it later. If you give them too much options, they will use it all, they will break it. So this is another interesting learning from this, but that's how small it is. We built a UI around it anyway, so for test environments, a non-production environment just creates an additional user experience, basically, to give them put stuff in the UI, copy and paste the template into Git, and also in the test environment, sometimes they just want to have the UI, so we built it on top of it. Nice thing is kind of the UI is not tightly coupled to the operator. It works against the Kubernetes API and this YAML file you saw earlier, so it's tightly coupled. Everything works nicely without like our UI and anything. The other ones, it's all going to Kubernetes and to the tooling and not some other way. The UI also tells you a little bit how the Bootstrap process is going. This is great, like for error detection when it gets stuck. You have the different steps along the way, like manifest, stateful set, pods coming up, pods doing the master election, and that's basically what you want to see. When it comes to integration, another thing that was great, earlier we had like LDAP, we had passwords to sync, and then people got the password by email, sent the password with the email back to us, and then you had to reset it, all this stuff. So we looked into how can we get rid of this, and what we basically already have in Zalando is like the platform IAM. Every employee can get like tokens to do REST API requests and so on, and we thought, okay, let's also use this for Postgres. Turns out it's quite easy. Postgres is extendable, and you can basically plug it into this PAM module, which is like a common Linux way. And this means we don't have passwords anymore in Postgres. People just copy in this dynamic token. It's valid for 60 minutes, and then they need to create a new token. It's kind of good for us. We get the multi-factor authentication for free because it goes via Google. Nothing to sync anymore, so we're not really dependent on external infrastructure anymore, and that turned out quite nice. We have a custom JDBC driver for local machines, so people don't need to copy anything at all, and that's quite convenient. Another thing, when you run something as a service, try to be transparent. I copied this from today because today it's still green. I wouldn't be lying if it remains green all the days. But what we see here is normally really good performance. And we are a little bit eager that when our monitoring, which is only 30-second resolution, detects something, we kind of mark it here as orange. But in the end, it looks really good from our side on normal days. Let's come quickly to monitoring before we go to learning. We obviously connected this to all the tools we have, and this means basically Zetmon, which you can find out there, which we still use at Zalando to do the whole monitoring of like everything that we have. But more than that, we also have a Postgres extension that's open source, so if you are a Postgres user, you should really have a look. It puts the REST API into Postgres and exposes all the essential data you want. And that basically gives people here real-time queries running, resources consumed, and that's pretty amazing in the browser to have. And yeah, the UI isn't open source yet, but we definitely plan to do it. It's not the greatest thing because we as a database team decided to do JavaScript coding in Riot.js. Not proud of it, but it's still helpful. And in the end, what's important here, we added a lot of buttons into the other tooling. So basically trying to give people a connected feeling, no additional logins, no looking up documentation. And in the end, where we really try to give them like a connected experience from all the different monitoring tools, deployment pipelines, where's their changes coming from. I have one slide here to mention like the open source projects we work on. The operator, The Docker image with Postgres inside, if you're curious. We talked about Docker yesterday and testing Docker. So Spilo has a Docker file. I think it consists of hundreds of lines, all connected with this end-end. So it's one huge shell script in one single Docker command. So have a look. Patroni, obviously a good thing if you want to do Postgres in a high available manner. We have the web-based monitoring extension here, which could be curious if you are using Postgres and want to expose this data. The OAuth part may be a little bit less interesting, and the blog post is also already there. So before we, let's go to the learning. So what did we learn? You saw earlier 200 databases in the data center, 160 on Amazon, EC2, and they almost never crash, so Patroni doesn't have so much work to do. We knew, obviously, from EC2, Patroni works very nice, and there weren't any surprises, but when you go from 160 databases to suddenly more or less 200 new clusters every 2 weeks or something like this, even if you find like a corner case for 5%, you quickly have like 35 clusters to fix on Monday morning. This never really affected like the master, the production database, but we lost quite a few replicas along the way of some corner conditions. It's not so bad. There is always 2 replicas. Data is on S3, so there wasn't a single incident, but you learn a lot about the corner cases, how stuff is shutting down in Kubernetes, how your Kubernetes to IAM role, and so on. So this was quite interesting, and Patroni has seen a lot of advancement around PG Rewind and so on, if you know what this is. So this was actually quite a good experience in the end, because otherwise you will just never see this, and then you only see it during a real incident, and you have no idea what to do. What's very important when you build this, and we didn't do this straight away, I can only encourage everybody to do this. Obviously, everybody knows this, maybe even from university, do testing. And this also includes end-to-end testing, but I'm still going to mention it here. Things will eventually break. Even like you had this Docker image 1.5 years in production, you're not changing anything, suddenly it breaks. And we released, for example, one Docker image where we broke the master election. It's kind of bad. Suddenly all the databases go into read-only mode. So you want to test this. Archive command. Somehow, out of the 1,000 databases, there were suddenly 11 that didn't ship archives to S3. Luckily, here, one screenshot, like in 2 minutes, we were able kind of to identify it all. So this is really great when you have a monitoring tool that is flexible enough to run stuff in production pretty quickly. So in this case, you just run a query on all production databases and see if the archiver is running. And then when you see it's only 11, you can kind of relax, but still a scary moment. We are the victims of our own success. We have more pull requests now basically from external contributors, and that's basically a problem because we had no external ability to run end-to-end tests. We have great success, I think, now with Kind. It looks really promising, so we're basically building all the test cases using Kind, and this means our external contributors can also run this on their local machine and make sure it still works. This should speed up our work on external pull requests. Fixed low-hanging fruits. Regularly, people create database names that are too long for the Kubernetes infrastructure. We still don't have the validation, but it's like annoying. If users have flags to create super user database users, they will do it. No matter if they need it or anything, they will create these super users and start breaking stuff. So don't give them this power. We did another thing, we over-optimized. So when we create a database in a new Kubernetes namespace, we don't create the service account more than once. So we remember, we have already seen this. It's stupid because people delete namespaces and then we never recreate the service account again and new clusters don't come up. So basically we optimized for this case of database creation that happens so rarely. And in the end, every month we have this 3-hour investigation where stuff doesn't work. So don't do it. You can actually write. What else do we have here? In general, why is our customer so happy? So we have role bootstrapping in there, so nice Kubernetes integration. I have 10 minutes left. I thought the signal was much less, so then we can make it slower. But maybe you have questions in the end. For Zalando employees, obviously I mentioned IAM tokens, very convenient to log in. Great integration into the deployment pipelines because you have the YAML file and the monitoring, so this is very well received. If you come from the outside, there's still stuff for you to benefit from. For example, this role bootstrapping. You put a role into your manifest, we create a role in the database, we put the password in a Kubernetes secret, and that's a much nicer flow because in the past you created a random password, you used some encryption, GPG, encrypted, put it into Git, all of this goes away. On Kubernetes, we also give you stuff like a master service and the replica service. So you can immediately starting like doing fallbacks if your read's failing, so increase the availability. You can connect to the replicas to do like production incident analysis without impacting the master. You can run the monitoring on the replica. When you compare with RDS, you can pay for multi-availability zone provisioning, which is good, but you can't use the second machine. You basically pay twice the amount of money, but you can't use the other one unless your first one fails. And if you want another one for analysis, you pay like a third time. We introduced cloning and restoring, so this is great. So our users, without talking to us, can do point-in-time recovery. So when they break stuff, which sometimes happens, they just say, okay, give me this database from 4 hours ago, deploy another YAML file, specify the time, and then it comes back with the data from 4 hours ago, basically before they updated or deleted or truncated their production database. This is really convenient. Works very well in general with all these tools like Flyway, and this is obviously needs a bit of education to tell people to use Flyway all the time. We still have teams, they go pSQL into the database, create a table, but that's not really what you want. You want really to encourage people to use migration frameworks, have all the code and the Bootstrap nicely implemented. From the user experience, what we initially didn't have so great is give users feedback when stuff is wrong, like don't hide it in some log message. And one of the learnings is this basically our UI for the operator has an in-memory buffer of all the log lines, and when we have an API, when we can show it in the front end, that means you don't need to go to any logging environment. You can just click on the right link and you see immediately all the logs for this cluster, what's really going on, and this turns out to be very convenient for us and for the other side. Then I was rushed to the end. I'm very happy to listen to questions or discuss Kubernetes or Postgres in general. Have a look at the open source thing if you are inspired by some of them. Thanks for having me. Sorry that I was a little bit quicker here. Maybe there's some.
Yeah, this is very unusual to be quicker than the time. So okay, we have a couple of questions actually, so we might be able to ask all of them. All right, so maybe from the most technical that can take the most of time. So from Wojtas, how do you distribute load to slaves, PG Bouncer, AWS internal load balancer?
We don't do this at Zalando. I think we have exactly 2 PG Bouncer deployments that have nothing to do with load balancing or anything. It's just because we went from non-SSL to SSL and it was hard to upgrade the client, so PG Bouncer does this for us. Teams have the master basically accessible on AWS. I mentioned here a Kubernetes service or Elastic IP, and that's what we use almost everywhere. And only very few tools decide they want to talk to the replicas. And then it's explicit coding, like then they have like a second data source in the application going to the replica load balancer or the Kubernetes replica service. And then it's like basic Amazon ELB magic or no magic, round robin, and on Kubernetes the same. So there is no major involvement in putting anything else in front. We never saw PG Bouncer. It has, I think, a few limitations when it comes to transaction scoping and so on. I'm not sure, but we simply don't use it, except one really technical case to bridge from non-SSL to SSL. And so far this is working well. These high load cases that we have, we put them on i3 instances, and then normally the single master is good enough. There is enough I/O there.
All right. The next one from Anonymous. Are you apps running on service accounts or tokens expire for them in 60 minutes like for humans?
So we have, I'm not sure if I'm getting it right, but the application, so the operator on Kubernetes has service accounts, so there is nothing expiring. But the normal Zalando applications that talk to REST APIs, they always have the same token infrastructure. So normal applications, they have a means to get a token, and they get a token, and with this token they can talk to other applications, and these tokens expire after 60 minutes. So the applications all have some logic to refresh tokens. But in Kubernetes, talking to the API is a service account, so slightly different.
All right. Why Kubernetes on AWS, not on GCP?
I think I would have liked GCP a lot, and probably so would others. But we already had like 2 years of Amazon footprint. We have a lot of knowledge on Amazon. Amazon in general is a pretty stable cloud. I think Amazon IAM, which you really need when you do stuff right, was at least in the past always ahead of the Google IAM solution. So there was like simply a lot of Google servers didn't have IAM. You couldn't manage privileges, and that's slightly different on Amazon. Yeah, I think just by experience, and then there's more stuff, but I can't really dive into it. You don't want to run multi-region. There's a lot of distractions for engineers to deal with two different clouds if you don't come up with super decent benefits from it.
All right, so I think that will be the last one. Can you compare stateful sets with PVC deployments? What's the advantage of stateful sets?
I think what we are, not a perfect answer, but what we are trying to do with the operator as one of the missions is do as little work as possible. And that really means like leverage the stuff that Kubernetes gives you. And the stateful set is called the stateful set for a reason from my point of view. And with the most recent change that it can also do pod management in parallel, not in the sequential manner, it gives you exactly what we want, a pod with an attached volume, and it makes by default sure they are distributed across the 3 availability zones. And I basically do not want to write code to manage any of this. So the more features Kubernetes delivers to us, the more code we're going to remove from the operator, like volume resize. Kubernetes is there to solve all of this. And when it doesn't work, I call another team. It's not my fault. And that's basically the whole idea here.
All right, so that's all questions. Since Jan is here and Postgres Kubernetes operator, I think, is the most popular now and most mature, please use him and get some offline questions. So thank you very much.